Hi, welcome to Math 1400, Nunez Community College. This section is section 4.1, which is the trig functions of any angle. So if we look at an angle where the terminal side of theta has a point, okay, we got angle theta, terminal side is a point x comma y. The radius is r. We can now find the functions or define the functions as the sine of theta is equal to not y, but y over r, because r is not like the unit circle where r is 1. In this case, we're going to have to find r. Cosine of theta is going to be x over r, and tangent of theta is going to be y over x. The inverses remain the same. The cosecant of theta is going to be r over y. The secant of theta is going to be r over x. And the cotangent of theta is going to be x over y. Now to find r, we'll pretend like this is a right triangle. We would have our x, we would have our y, so we would use the Pythagorean theorem to find where r would be equal to the square root of x squared plus y squared. So on the first question it says, let negative 3 comma 4 be a point on the terminal side of theta. Let negative 3 comma 4 be a point on the terminal side of theta. It then says, find the trig functions sine, cosine, and tangent for theta. So if I draw this up here, negative 3, 4 will be over here, negative 3 and 4. Okay, this is the terminal side. That's my theta. We can find the r, whether we make it into a triangle or not. This being negative 3, this being 4, find the r. We have what? Negative 3 squared plus 4 squared equals r squared, which would give me 9 plus 4 equals r squared. R squared equals 25. Take the square root to get r. R equals 5. So in this case, r would equal 5. Now, given what we have here, with that being on the terminal side, we can find that the sine of theta is equal to y over r, or in this case, 4 over 5, 4/5. Cosine theta is x over r, or negative 3/5. And tangent of theta is going to be negative 4/3, y over x. We could find the other three, but in this case, they're only asking us to find sine, cosine, and tangent. We can figure what quadrants the angles are positive by drawing a coordinate plane, and we can look at it. In quadrant 1, all 6 trig functions are positive, have a positive value. That's the sine, the cosine, the tangent, the cosecant, the secant, and the cotangent. All are positive. In quadrant 2, the ones that are positive are the sine and the cosecant, which is its inverse. In quadrant 3, the positive functions are the tangent and the cotangent, its inverse. And then in quadrant 4, we have the positive, which is cosine and secant. Cosine and secant is positive in the 4th quadrant. Okay, from here, we're going to have to know what quadrant we're in given certain information. Suppose we have that the sine of theta is greater than 0, And the tangent of theta is less than 0. What exactly does greater than 0 and less than 0 mean in this instance? Well, greater than 0 means that it is a positive number. Less than 0 means that it is a negative number. So my technique that I would use for this would be to draw two coordinate planes and check off where it applies. Check off where it applies. So let's draw the two coordinate planes. In this case, for the sine, I have the coordinate plane and the cosine. The tangent I have the coordinate plane. So we said that the sine of theta was greater than 0, which means the sine of theta is positive. Also, we look at it and we said that all trig functions are positive in the first quadrant, so I'll check that off. And that the sine is positive in the second quadrant, so I'll check that off. So I know the quadrant that we're in has to be either first or second. I look at the tangent, and the tangent of theta is less than 0, which means the tangent is negative. Less than 0 means negative. And tangent is positive in the first and in the third, which means it's negative in the second and the fourth. Negative in the second and the fourth. Since both of them meet up in the second quadrant, we would be in quadrant 2. If we had to find what quadrant we're in based upon the positives and the negatives. So from here we're going to be given that tangent is a value. Given that the tangent of theta is equal to negative 5/4, and that the cosine theta is greater than 0. So we're looking for where the cosine is positive and where the tangent is negative. So again, I'm going to make my two coordinate planes and we're going to see where we end up. Tangent is negative, we said, in the second and the fourth quadrants. Cosine is positive in the first and second quadrants. So since we meet up in the second, that's where we're going to put our tangent value. So I'll draw this. We'll have theta. Okay. I know that tangent is y over x. Y over x. So in this case, we'll put our y as 5 and our x as 4. And it's y over x. The x value has to be negative because to the left of the number line, the x values are negative. We can then find our r so that we can put the put our values in. Negative 4, 5 would be our point. This is written as a right triangle. This would be just written as a point. And what do we have here? It would be what? Negative 4 squared plus 5 squared equals r squared, or the hypotenuse squared. We have what? 16 plus 25 equals r squared. R squared is equal to 41. R would be the square root of 41. R would be the square root of 41. 41 is a prime number, so it does not break down, so the square root of 41 is what we're going to leave. They then say that we would like to find the value of all 6 trig functions. So we want to find the sine of theta and the cosine. Find the value of all 6 trig functions. So I can list what we just did, which is the sine is going to be y over r, or if you look at it from in here, the sine would be opposite over hypotenuse. But again, we have what? 5 over the square root of 41. The cosine being x over r would be negative 4 over the square root of 41. And the tangent given to us already was negative 5 over 4. Now to find the others 3, I'm going to use the inverse property in order to find them. I left this way with the radical on the bottom, but it cannot be left that way. So I'm going to rationalize the denominator in just a second. But for now, I'm going to put this as negative 4/5, the inverse. I'm going to put this as negative square root of 41 over 4. And here we have square root of 41 over 5. The reason that I left it is because when I do the inverse, I can have a radical on the top. I can have a radical in the numerator. I just can't have it in the denominator. So for this one, I'm going to take 5 over the square root of 41, and I'm going to multiply by the sneaky form of 1, which is the square root of 41 over the square root of 41. Again, whatever I'm trying to get rid of is what I multiply over itself. On the top, I have 5 square root of 41 over the square root of the number times the square root of the number is the number, 41. So this would be 5 square root of 41 over 41. For the second one, we're going to do the same process. Can't have a radical on the bottom. Multiply by the sneaky form of 1, which would give me negative 4 square root of 41 over 41. And this would be the 6 trig functions given that information. Again, each thing we're building upon just a little at a time, building upon just a little bit. The next thing we're going to look at is we're going to look at something called reference angles. Reference angles are angles that we refer to in the first quadrant. Because if we remember that big unit circle, there was a lot of angles that we messed with, that we dealt with. But as you noticed, the ordered pairs were the same. The ordered pairs were the same exact fractional numbers, except some were positives and some were negatives. So we're going to use reference angles in order to find those same values, and then we're going to use the one that we have over here for the positive angles to be able to determine whether or not our answer is positive or negative. So for the first one, if we have an angle that is in the second quadrant, if we have an angle that's in the second quadrant, these are reference angles. Reference angles. So, all right, we have an angle in a second quadrant. Here's my theta. The angle that it's going to refer to in the first quadrant is going to be however far it takes to get to the next y-axis. However far it takes to get to the y-axis. We're going to call the reference angle theta with a little tick mark, otherwise known as theta prime. If it's in the second quadrant, we're trying to find theta prime. We have to take 180 degrees minus the original angle theta gives me theta prime. Or theta prime is equal to, in radians, pi minus theta. If it's in degrees, it's 180 degrees minus theta. If it's in radians, it's pi minus theta. That would give me my theta prime. And this is in quadrant 2. If we're in quadrant 3, I'll draw an angle in quadrant 3. That would be my theta. In order to get back to the y-axis, the closest way back would be to go backwards. This would be theta prime. And if we look at it, theta prime would be equal to the whole angle theta minus 180. So it would be theta minus 180 degrees to give me what we need to get to the y-axis. Or theta prime would be equal to theta minus pi. And then finally, if we're in quadrant 4 and we're looking for the reference angle, say we have this here, that's my angle theta. We just go back to the y-axis, or the closest way to get back to the y-axis. This would be my theta prime. And if we look at it, it would be what? The whole thing minus the theta would give me theta prime. So theta prime would be the whole thing, 360 degrees, minus theta. Or theta prime would be 2 pi minus theta. 2 pi minus theta, if we're in radians. So now, if they ask us to find some reference angles, suppose that theta was 300 degrees. We have to know which quadrant that theta is in so we can find the reference angle. 300 degrees we know is in quadrant 4. So in order to find the reference angle, theta prime, it's going to be equal to 360 degrees minus 300 degrees. Theta prime would be equal to 60 degrees. So again, it would refer to the angle in the first quadrant, that would be 60 degrees. Suppose we had the angle of 2 pi over 3. The angle of 2 pi over 3. Well, 2 pi over 3, what quadrant? Second quadrant. So we would know that theta prime would be equal to, according to this, pi minus theta, pi minus theta, which is 2 pi over 3. In order to subtract fractions, I have to have a common denominator, so that would be 3 pi over 3 minus 2 pi over 3, and theta prime would be pi over 3. So pretty much you have to know or recognize what quadrant you're going to be in and know whether you're doing the degrees or the radians. And finally, what happens if theta is 2.3? 2.3. First thing we ask is 2.3, is that a degree or is it a radian? And the answer is, it is a radian. So we then ask ourselves, what quadrant would we be in? Well, we're not used to seeing it with just a number. We're used to seeing it in terms of pi. So we say, all right, well, where is pi at? Pi is 3.14. 2.3 is less than 3.4, so we must be in quadrant 2. So in order to find our reference angle, theta prime, it's equal to 3.14 minus 2.3, and theta prime comes up to be 0.846, yes, 0.846. And that would be radians. Now we can get more specific in using all of the information that we've been given, to find specific answers. For instance, suppose it says that they want us to find the cosine of 4 pi over 3. The cosine of 4 pi over 3. Well, I'm going to have to draw the 4 pi over 3, and we're going to go from there. Okay. So 4 pi over 3, we should be looking at that and saying that it probably is in the third quadrant, because 3 pi over 3 is going to be at pi. So 4 pi over 3 is going to be down here. And it is 4 pi over 3. And we're trying to find what the cosine of 4 pi over 3 is. Okay, so we are going to have to find the reference angle, because the reference angle is going to tell us the value that we're looking for. So I'm going to find the cosine of the reference angle, reference angle theta prime, since it's in the third quadrant, is going to be what? Theta minus pi. So theta prime is going to be 4 pi over 3 minus 3 pi over 3. Theta prime is pi over 3. So that's the first thing we're going to do is, since we're trying to find the cosine of this, we're going to find the cosine of the reference angle. Cosine of pi over 3, well, I know that pi over 3, the ordered pair is 1/2 square root of 3 over 2. Again, that's ones that we need to make sure we know. Pi over 3, or 60 degrees, is 1/2 square root of 3 over 2. Why? Well, because the x value is smaller than the y value. And then 1/2 is a smaller number than square root of 3 over 2. So, again, cosine of that is going to be 1/2. So if the cosine of pi over 3 is 1/2, the cosine of 4 pi over 3 is 1/2. The cosine of 4 pi over 3 is 1/2. But now we have to ask ourselves, we had what? Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Here all the functions were positive. Here the sine and the cosecant was positive. Here the tangent was positive, and here the cosine was positive. So since we're in the third quadrant, the cosine is negative. So since we're in the third quadrant, cosine of pi over 3 is 1/2. Cosine of 4 pi over 3 is negative 1/2. Cosine of 4 pi over 3 is negative 1/2. Suppose we're trying to find the cosecant of 11 pi over 4. Cosecant of 11 pi over 4. Well, we have to find where it's at, and we also have to find the reference angle. 11 pi over 4, well, this would be what? 8 pi over 4, because that's 2 pi. 9, 10, 11 would be back at 3 pi over 4, which would be here in the second quadrant. This would be 11 pi over 4. So again, this is 8 pi over 4. This would be what? 9, 10 pi over 4. This would be 11 pi over 4. So the reference angle there is going to be pi over 4. And we can find the cosecant of pi over 4. The cosecant of pi over 4 is going to be equal to what? 1 over the sine of pi over 4. 1 over the sine of pi over 4. And the sine of pi over 4 is what? Square root of 2 over 2. Because pi over 4, we know our ordered pair is square root of 2 over 2, square root of 2 over 2. So we got square root of 2 over 2. The inverse of that is going to be what? We're going to do 1 over the sine of pi over 4 is going to be 2 over the square root of 2. Flip it. So the cosecant of pi over 4 is going to be, we what? Multiply by square root of 2 over square root of 2. And we get what? 2 square root of 2 over 2. Cancel out the 2's, so square root of 2. So the cosecant of 11 pi over 4 is the square root of 2. But in the second quadrant, cosecant, sine in the second quadrant is also positive. So therefore the cosecant is positive. So the answer would just be square root of 2. The answer would be square root of 2. And then finally, suppose we had to use a calculator to find the equivalent of certain numbers. Suppose I have the cotangent of 410 degrees. Cotangent of 410 degrees. So we want to round this to 4 decimals. First thing is, we don't have a cotangent button on the calculator. We do, however, have a tangent button on the calculator, and we know that the cotangent is equal to 1 over the tangent. So I'm trying to look for what is the cotangent, which is equal to 1 over the tangent of 410 degrees. So we punch that in and we come up with the tangent is 1.1917. This is 1 over 1.1917. And when we hit the inverse button, or 1 over that, we come up with the answer, which is going to be 0.8391. 0.8391. By the way, very important, 410 degrees, set calculator to degrees. Set the calculator to degrees. If it's in radians, you set it to radians. If it's in degrees, you set the degrees. Suppose I have the sign of -7. Again, -7 does not say -7 degrees, so we set the calculator to radians. We punch the sign, we hit -7, we close our parentheses, and when we hit enter, we should get -0.6569. -0.6569. And then finally, suppose we're looking for the cosine of pi over 9. Set to radians. Always make sure your mode is set to the right thing. Set to radians. Punch in cosine. It should be an n over d button. Pi over 9. Hit enter. And we should come up with approximately 0.9396. Well, this has been section 1.4, which is the trig functions of any angle. Hopefully it helped out a little bit. Catch you at the next one.